Assalamualaikum. Today we'll be presenting about application of differentiation in electrical engineering.
We are from class J4 CEEH 1101E and our group name is Maple equal to Apple. Our team members consist of me, myself, Nur Qurratu Aini binti Wihizat.
Hi, my name is Muhammad Hasri bin Hasri.
Hi everyone, my name is Arianna.
My name is Muhammad Aidil bin Ahmad Faizal.
My name is Nur Izzati binti Arifin. You can call me Izzati.
Introduction of differentiation. So what is differentiation? Differentiation is a method of finding the derivative of a function. It is a process to find the instantaneous rate of change in function based on one of the variables. So next, we go through to see what is related rates. So related rates is when two or more rates happening at the same time, possibly at different rates. In calculus, the rate of one variable can be determined if the rate of another variable is known. This generally involves writing an equation that relates the two variables and deriving the equation with respect to time. Chain rule method becomes important to solve these problems. So next, we're gonna go through to introduction of electrical engineering. Electrical engineering is a field of engineering that deals with the study and application of electricity, generation, transmission, distribution, and consumption of electrical energy for the benefit of mankind.
So next we move on to application of this differentiation in electrical engineering. Calculating voltage or current across a capacitor necessitates the use of differential and integral calculus. Calculating the precise length of a power cable required to connect substations that are kilometers distant from one another also heavily relies on integral calculus. So differentiation in electrical engineering. First, the current and the voltage. To calculate the change of the current and the voltage through a resistor that can related by V equal to IR. Next, a capacitor and an indicator. Apply in Ohm's law to calculate the relationship between voltage, current and resistance in electrical circuit. Lastly is amps and bulbs to determine the number of amps and bulbs needed for the project.
Electric power is being supplied in a circuit at rate 5 watt per second. Determine the rate of change of the EMF of the battery after 23 seconds. Given the intensity of current is Q equal to 3T square plus 2T.
Okay, so based on the problem statement, it says that electric power is being supplied in a circuit at rate of 5 watt per second. So we knew that 5 watt per second is actually dW over dt. And then it says to determine the rate of change of the EMF of the battery after 23 seconds. So we all knew that T is equal to 23. And rate of change of EMF is actually dW over dQ. Because the formula to find EMF is W over Q. It's given that the intensity of current is Q equal to 3T squared plus 2T. Okay, so the first thing that we need to take is to jot down every information that we know. Power, which is equal to dW over dt, is equal to 5 watt per second. And the intensity of current, which is Q, is equal to 3T squared plus 2T. Okay, then the next step that you need to do is to differentiate Q with respect to time. So dQ over dt, you will get 6T plus 2. Okay, so right now, notice that you already found dW over dt and dQ over dt. So you can actually find the rate of change of the EMF by using chain rule. Okay, so dW over with dQ is equal to dW over dt times with dt over dQ. Okay, so we already get the value of dW over dt. But notice that over here, we only have dQ over dt. We don't have dt over dQ. But actually, 6t plus 2 is over 1. So in order to find dt over dq, you only have to flip the equation. So you will get 1 over 60 plus 2. Okay, then just sub the information inside the equations. So 5 times with 1 over 60 plus 2, and you will get 5 over 60 plus 2. And then we knew that it asked us to find the rate of change of the EMF after 23 seconds. So when t equals to 23, just sub the value of 23 inside the equations. 5 over 6, 23 plus 2, you will get 1 over 28 volt, which is the EMF of the battery.
So the question what we have here is the volume of a cylindrical battery used in a circuit is given as V equal to pi r square h, where the height of the battery is always double of the radius. If the volume increase at rate 324 pi cm volume per second, find the rate of change of radius when the radius is 3 cm. So I will let my friend Aini to explain more how to solve this question.
So for this question, they already gave you the volume of cylindrical battery used in a circuit, which is V equal to pi r square h. And the height of the battery is double the radius, so we knew that h equal to 2r. If the volume increased at rate of 324 pi centimeter cube per second, find a rate of change of radius when the radius is 3 cm. So we knew that r equal to 3. 324 pi centimeter cube per second is actually dV over dt. And they asked us to find the rate of change of radius, which is dr over dt. We need to find this. Okay, so same like previous one, we have to jot down every information that we knew. So the first one that we knew is dV over dt is equal to 324 pi centimeter cube per second. Next, we knew that h height is equal to 2r, while r is equal to 3. Remember that they also provide the volume of cylindrical battery, which is V equal to pi r square h. Notice here, you already have the value of h, so you can directly substitute it inside the equation. So, pi r square h, you replace h with its value. So, substitute 2r, you will get 2 pi r cube. Okay, now, you have to differentiate V with respect to t. I mean with respect to r. So, dV over dr equal to 6 pi r square. Okay, so right now, you already have the value of dV over dt and dV over dr. So, you can find the rate of change of radius by using a chain rule. So, dr over dt equal to dr over dV times with dV over dt. Okay, notice here, you only have the value of dV over dt, but you don't have the value of dr over dV. You only have the value of dV over dr, but it's actually same like the previous one. 6 pi r square is actually over 1. So, dV over dr is equal to 6 pi r square over 1. So, dr over dV is actually equal to 1 over 6 pi r square. So right now, you already have the value of dr over dV, so you can directly substitute it inside the equation. So 1 over 6 pi r square times with 324 pi centimeter cube per second, but you don't have to write it. Notice here you have both equation have pi, so you can cancel out the pi. So the final answer, you will get 324 over 6r square. So remember that just now they asked us to find the rate of change of radius when r equal to 3. So when r equal to 3, you only have to substitute the value of r inside this equation. So 324 over 6r squared, replace the r with 3. So you got 3 squared. You will get 6 centimeter per second. So that will be the final answer for the rate of change of radius when the radius is 3 cm.
In conclusion, calculus is very important in electrical engineering to determine the value or change of electric current. For example, solve the given problem using the chain rule concept to find the value of the rate of change. Last but not least, from all the videos my teammates have explained, we know the meaning of relative rate and how it is used in electrical engineering.